Hey students, welcome to this little overview of your homework assignments for this week. I'm going to look at sections 5.2 and 5.3. 5.1 didn't have much TI help that I could give you, nor could I find much in 5.4. Definitely a lot of algebra going on in these four sections this week in 5.1 through 5.4. So I wanted to specifically look at a few questions in 5.2, starting with number 8. This first one says find the real zeros of f and use the real zeros to factor f. We're just going to address finding the real zeros. Anytime you're given that indicator, you pretty much know the real zeros should appear on your TI. So I've already input this function in here, x cubed minus 3x squared minus 25x minus 21. And then you'll notice next to y2 I put 0. Now that's because I use the intersect command. Some of you use the 0 command on your calculator, and if you use that, then obviously you don't need y sub 2 equal to 0. So here's what I'm going to do. I'm going to go ahead and graph it, and then I see this graph. Now, you've already learned by now that if you have a degree 3 equation, you have at most 2 turns. Well, there's my first turn, and then obviously somewhere down here there's a second. But there are my 3 zeros right here. Now my hope is that none of these are decimals. And if they aren't, I can just use my TI to find them. And to do that, I press second trace 5 for intersect, and then just press enter 3 times. Now my cursor was here, so it's going to give me the nearest intersection, or the nearest 0 to where the cursor was. So you can see my first 0 is at -1. Now I want to find this one to the left of it, so I press second trace 5, but before I press enter 3 times, I just move the cursor anywhere over here closer to this intersection, then press enter 3 times. And there's -3. So I'm 2 for 2 on this one. Now I'm going to try to find that one all the way over there. So second trace 5, then just hold down that right arrow. Looks like a falling star. And it's going to come back over here at some point. Now I know I'm close enough. I'm at 6, so if I just press enter, 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 there's my third 0. So the reason why I show you this is because some of you click on these crack buttons over here, view an example, and I just want you to notice all the work. They have you use the rational zeros theorem and great theorem. They have you do all this testing, bounds, work, and I'm just showing you, hey, you know, when you learned how to solve a quadratic equation, you started with factoring. Then we teach you the quadratic formula later on. You know, if you can ever factor a problem quickly, there's no point in using the quadratic formula. And in these problems, if your TI can give you the answers quickly, there's no point in going through all that work. Now, that of course does not apply to all these, but I just wanted to show you I can help you out, save a little time here. Number 10. Let me enter this one in. Now, 10 should be obvious that this is a TI question. I'm going to go ahead and input it. X to the power of 3 plus 2.1 x squared minus 20.62x minus 15.12. The reason why I say this should be obvious is because you have decimals here, and down here it tells you can round to 1 decimal place. When we see that, we know we're golden when we're looking for real zeros and we're allowed decimals. So I press graph. I'm looking for, do I have 2 turns in my viewing window? I do. There's 1, there's 2, so I know the entire graph, or all the zeros are right here. And then I just use the same command, second trace 5, enter, enter, enter for the first one. Round that, well, that doesn't need to be rounded. And just find the other 2, and I'm done. Go to the last one that I wanted to show you from this section, number 12. So it says find the real solutions, but notice the directions say exact answer. That means if we end up with some nasty looking decimals in here, we're not going to be able to use the TI. We can use the TI to verify, but not to find the exact answer. And some of you know what I mean by exact answers. That's the radicals. If you have the square root of 5, let's say, is a 0, I don't know how to find that on the TI. I can get the decimal equivalent, but to get the decimal to convert to a radical, I've never done it. So you'll have to do it the old-fashioned way, and that's with some hard work, some elbow grease, and some paper. So let's see what happens on this one. Here's the graph. Okay, I see two turns, the turn here, the turn there, so I know the entire graph is covered. Now second trace 5, press enter 3 times, I end up with this decimal, not looking good. Let's try it again, second trace 5. Now there could be a second one right next to it, probably is, but just going to show you what I would do. See, that doesn't work. So now when you look at your directions, or if you're reading the book, you will see you do have some work to do on this one. So from there, I just wanted to give you a little heads up that sometimes you can save yourself some work, and I am all about efficiency when I teach my classes face-to-face, so I would show you this in the classroom. Now, bear with me one second. I'm going to pause this. Okay, after a brief pause, I went ahead and brought up assignment 5.3, and in here I went to problem 15. Now you'll notice the directions have changed from real zeros to complex zeros. So that involves the i's, the imaginary numbers, and others that, again, your TI is not going to find for you. But I can save you some steps, and here's what I want you to look at. In the example, they have you use the rational zeros theorem to determine all the potential rational zeros. You go through all this trial and error, then they tell you to use the calculator. Don't know why they saved it for that long, but they say, oh, there might be one right here. Let's check it. You check it, you prove it, and then from there, you now have to use synthetic division to finish the problem. Now, can't prevent the synthetic division, but all these pre-steps, I don't understand why we can't just go right to, hey, here is a 0, this is a real 0, let's use it. So looking at this problem, when I go to graph it, I'm going to press zoom 6 because I've messed my window up a little bit. So zoom 6 always resets it. I see this curve. Now this is a degree 3, so there could be another turn. And if you're not sure, you can blow up the window a little bit by expanding, from -50 to 50. Change your scale, and then y-axis, it really doesn't matter. We just want to know, does this thing come back down? And you'll see that it doesn't. It just keeps going. So let's find that 0. So second trace 5, enter, enter, enter. And we see that we have a 0 at 2. So again, what does this help us out with? Well, instead of trying the rational zeros theorem, and again, I'll bring up the example that they give you, instead of going through all these potential zeros, graphing it, testing it, and then getting to synthetic division, you might just want to use your calculator and see if there's one there. If there is, go straight to this step and start working the problem. Again, it's just about efficiency. I will do my best throughout this course to assist you with efficiency. I think that's the way the world goes with everything that we do. Not saying I'm a proponent of it, it's just the way it is. So hopefully this helps you out, and look for another one of these in the next couple weeks.